So hi everybody, my name is Tom Emrich and I'm going to be moderating this discussion. I think it's a very important discussion to be having when we're talking about augmented reality and virtual reality. Our space is so focused on sight and there is still a lot to be done when it comes to smart glasses, HMDs and helmets, and there's no surprise that in this technology space, as we move from one wave of computing to the next, we continue to be dominated by the screen because every wave before it has been very screen-based. But what's really different about AR and VR is that we're putting together what's called immersive computing, and we frankly can't be talking about anything immersive if we're only putting one piece of our humanity inside of this next wave. And so this panel is talking about putting the rest of your body inside of augmented reality and virtual reality in order to interact in a much more natural manner. And we have some amazing thought leaders that are leveraging different senses and sensors and are leveraging different methods to bring our arms, our hands, and other input mechanisms into AR and VR from Emteq, Kinemic, MASSLESS, and SoftKinetic. And I'm going to let them introduce themselves, their company, and how they fit into the space, starting with Graeme.
Thank you very much, Tom. I'm Graeme. I'm the CEO of Emteq. We're a UK-based company building AI wearables, specifically glasses that are reading facial movement, head movement, physical response for arousal indicators, various other sensor formats, and translating that back into expression and an understanding of emotion. So, in short, glasses that read your emotions, reading the wearer's emotions, not reading the emotions of those around you. We are delivering those as integrations into VR headsets as well, and what we've been demonstrating on our stand, and I was talking about this morning, is an integration with lifelike digital avatars, showing that emotional translation from the face directly in real time into the virtual world.
Great. Eric.
Thanks, Tom. So I'm Emrich Krzeslo from SoftKinetic. So we are essentially doing two things, one hardware piece and a software piece. The hardware piece is a depth sensing camera, so a camera that sees in 3D. And on the software side, we're a specialist in human tracking and gesture recognition. So our technology is really there to improve the human-machine interaction. We are active in mobile, in AR, VR, in automotive, in industrial application. It's really all about better interaction between humans and machines.
Christoph?
Yeah. Christoph from Kinemic, and we are also doing software for gesture recognition, but in contrast to you, we are not using cameras, but motion sensors or inertial sensors that are, for example, integrated in a small armband, and you can do, for example, swiping gestures or things like that to control your smart glass hands-free. And since we use inertial sensors, they operate outside in the field. They are independent of any kind of environmental effects, and so we want to improve the way we can interact with those glasses if you're really outside in the field.
Great. And Jack?
I'm Jack. I'm the founder of MASSLESS and the inventor of the MASSLESS pen, which is the first pen for virtual reality. So you can now draw in 3 dimensions, and soon we'll be able to use it in 2D as well. So this is literally a replacement for a graphics tablet, except now we have an extra dimension that you've been missing. And engineers and designers around the world are creating 3D things using 2D tools, 2D screens and mice, which makes no sense. It makes much more sense to make 3D things in 3D, and that's what we provide. But in order to do that, you need a very precise tracking. So we provide these precise interaction devices, and the pen is just the start of that.
Great. So I'm going to lead this conversation, and then I'm going to open this up to audience questions. We're using Slido in this room, so if you go to slido.com and access it via hashtag AWE2017, and choose Hall 1 as an option, you can write out your question, and then as an audience, you can upvote the questions. So when we interact with you, we're going to bring up the questions, and then we'll be answering them accordingly. So as we're starting to have these conversations here, please use slido.com and start to put your questions in the queue so that you can be part of this conversation as well. So I think it's good, gentlemen, to start off by just talking about what the current state is. So you're all working on some fantastic technologies. And I think we probably have to talk about AR and VR interaction from a consumer perspective and an enterprise perspective separately. So let's just start in the consumer space. When it comes to AR and VR, where are we at with interfaces? What is and isn't being used?
I think we are not very far, actually, especially for VR. So just my way of looking at that, especially for VR, it's all about feeling to be somewhere else and living another experience. And to achieve that, you need actually to mimic or simulate all our 5 senses, like sight, hearing, haptic feedback, smell, and taste. And then you can really feel you're somewhere else, right? And what do we have today as an inbound interaction? Not a lot, right? We've got sound and we've got sight. That's it. And there are some experiments for haptic feedback, etc. So, but not very far, right? And for the outbound interaction, so how to interact with the virtual world, it's even worse. We have practically nothing today, right? A little bit of gestures that we are doing, that you are doing. Haptic feedback, again, or physical interaction, it's not there. Walking, there are a lot of interesting things, and including the show floor, we're just discussing about those cyber shoes. It's very interesting.
A lot of plugs for cyber shoes. Everybody's going to be running out and getting a pair of those.
Yeah. But it's really the beginning, right? And what about, so there is a little bit of voice interaction, okay? Not a lot, but what about, again, physical interaction or gaze tracking, facial animation that you are doing? So it's not there yet, right? So there are still a lot of things to be developed and new technologies to be out there to really have that super immersive experience that we all want to have.
Anybody else have some thoughts on that?
Yeah, I mean, absolutely. In the if you look at social interaction in immersive environments, for example, we see that the paucity of quality of animation of the avatars that you're being represented by are definitely a block to that sense of real connection. And exactly as you're saying, the promise of an immersive environment is exactly that it's genuinely immersive. And we're still at very early stages in understanding how to properly project ourselves into an immersive environment to give a natural effect. But there's lots of promise. It's early days, but yeah.
And the other thing is that, but how far do we need to go, right? We want to have an immersive experience, but we don't want to have a fully realistic experience. Like if you are playing a car simulator game, you don't want to die when you crash, right? So for real. So how far should the realism go?
Yeah.
And so just speaking about that, so obviously we're not there, right? I'm sure a lot of people have read Ready Player One. There's this, this whole rig setup that seems just unimaginable to have in anybody's apartment these days. That really provides a much more immersive experience. But it sounds like we're really not there on haptics. We're not there on gesture or even voice. There's still some work to be done. But we are augmenting all this with peripherals and controllers. And maybe Christoph and Jack, you can talk a little bit about the role that controllers and peripherals on the hardware side really provide on the consumer space in AR and VR, or even on the enterprise side if you want, and how you see that evolve as some of the non-controller and non-peripheral technologies start to really become more robust.
Yeah, I mean, obviously if you use a smart glass or augmented reality glass, you don't want to use a controller that you have to hold in your hand, right? That is just perfectly wrong. And so it's more about putting the technology directly on the body to directly sense the movements. And I think there is a lot of new technologies out there, and it's not yet clear which is going to work well. I mean, you have the HoloLens, which uses a time-of-flight camera, but then it's still limited what you can do with it. You have things like Project Soli from Google, which was announced, but it's a bit calm at the moment, and so it's not that easy, obviously, to get it running up. And then we do something with inertial sensors. So, but I think that's the right direction, to have interaction without having to manipulate anything, right?
Yeah, I maybe have a different view from everyone, because I'm not sure I really want this matrix kind of world to happen, like where we have a completely immersive experience where you can't tell reality from, from virtual reality or whatever you want to call it, mixed reality. But certainly what's important for me is we have just broke through this barrier in humanity where we can control everything that we see around us. Just the vision, every object we can, control in 3D now. So we have this access to this 3D space. So the next important step is really a great user experience when you're manipulating this space. Like, how can we create things? Like, we can see anything we want, but how do we actually interact and create things with this? And the key there is an excellent experience with these user input devices. And you've got things like the Vive controllers, which are huge. They're so heavy. People that use them for a long time have a lot of injuries and aches. So that's not suitable. And then the Oculus is still very much for games. It's not anything for precision. So obviously I'm doing a plug for MASSLESS here, but
Seems well set up.
Yeah. What we really want when we move into this 3D space is a great spatial interaction experience. It's got to work really well, and that's what I think is important. Right?
And from your perspective, that's still holding something. Like you have a physical pen.
Well, yeah. So again, I'm very biased from MASSLESS, but if you look at evolutions of humans, the most primitive thing you can do is use your hands. So you use your hands and you can make clay things, but we evolved to use tools, and we're the only species that really evolved to use precise tools. So the pen is one of those precision tools, like a scalpel, like tweezers.
Right.
If you want precision control, you do need to hold something. It's just it's a function of anatomy.
I see.
But really, it'd be great to have precision hand tracking. So I think that's an important thing to do. But it's actually easier to get these more sophisticated tools to us today, which is what MASSLESS is doing.
So do you see a future in where we still have tools, like physical tools that we use within these spaces, or and I'm going to open this up to you three, because all of your technologies are toolless in a way. You're not actually physically monopolizing your hands with something; you're leaving them free. What does that future look like? Is it a mixture, or is one going to win out? Is it a war?
Yeah. So you briefed us. We should disagree.
Yes, I'm trying to create that
but
argument.
I cannot disagree yet, because actually I agree with my colleagues here that it's indeed a mixture of natural. The whole point is to have a natural interaction. Yeah. Okay. And so sometimes natural interaction is without anything, right? When you talk with someone, or right, and sometimes you need, if you want to draw something, you need a pen, right, to make a nice drawing. So it's going to be a mixture of tools, natural, non-invasive interaction. So yeah, everything needs to go together. Of course, we're still pushing our own technologies, trying to convince the world that you don't need any tools. But we know that it's a combination of all that would be successful at the end.
Okay.
I think there's a difference between VR and AR at this point, because in VR, I think it's perfectly fine to use tools. You're in a very restricted space, and so I think if this adds to the experience, it's perfectly fine. But if you are using an AR system during work, or a smart glass-based system, then you want to use your hands for other things, for the work you have to do, and then a controller is not good at all.
And so on the gesture side, where are we at with it? So you're both kind of using gesture from opposite ends of the solution, from an optics and from and motion. But what are some of the technical challenges that need to be overcome in order for it to really be something you can just pick up and use all the time? Or are we already there yet?
I think we're. You want to go?
Okay, I can begin as well. So I think like the holy grail would be accurate finger level tracking without.
We have to.
Yeah. Does it work outside in the dark and everywhere?
And that's because of time of flight. Yes.
Yeah. Okay.
Because of our special sensor.
Okay, so you have the solution already for that.
But then I can talk about the
Yeah.
challenge.
Okay. So it has to be mobile. So it has to be. It has to be working everywhere, and it needs to be down to the fingers, and that would be great to have. But I think currently a lot of different technologies are in the ring, and when it comes to robustness and usage out in the field, then cameras are often not the best thing to do. But maybe you want to disagree. Yeah.
Yeah, okay, I'll disagree. So you're happy. So I think it's a question of context. So in terms of accuracy and robustness, for instance, we have deployed our technology in cars for controlling your infotainment system, like music, GPS, phone calls, with small gestures. So you can keep your eyes on the road, you're not distracted, and you can interact. And that was that's for a famous German car brand, and they are all about quality and robustness. So we needed to achieve like close to 100% true positives, and that works. That's deployed in the product. But because the context was very clear, and the interaction that we needed to do were very clear, so we're very far away of having a system that will work in any situation, for any gesture, for any interaction. That's I don't know when it's going to happen, if that happens sometimes. But when you know the context and if you know what you want to do with the system, then you can really reach a super high level accuracy. So that's really a question of context, I believe.
And I think, Graeme, you can probably speak to this a bit too as well, in terms of the accuracy, especially when you're talking about emotion and using EMG and optics to read facial expressions. How important is context, I guess, is the bridge, I thought.
Context is hugely important. I think, firstly, just to echo what you're saying, when you're in an environment like constrained within the cab of a car, it's a perfect environment to use cameras to monitor the individual, because you can't move that far. There's only so many different things you can do within the context of sitting in that seat. And similarly, when you're sitting in front of a laptop and you've got a web camera pointing at your face, it's a really good environment in which you're going to be able to monitor a lot of facial information, do a lot of facial tracking. Context is really easy to understand there. You know what that person is doing broadly. They're looking at the screen, interacting. When you take that out into the real world and you take it into all the other situations where there isn't naturally a camera pointing back at the face, and you don't have easy access to the context of what the person is doing, then you are solving some really knotty problems. And that's what we're aiming to do, to provide that facial expression and response information for all those times when you are not sitting with the camera at a fixed distance away from your face, which is most of the long-term use cases for augmented reality.
So let's move off a little bit of the hardware and the technology and move a little bit to some of the human challenges, as well as how this is all changing interaction. Because one of the things, there's kind of two things that comes to mind across all four of you. One is, we're just not used to using our body with technology. We have a keyboard and a mouse, and it's flat. So when it comes to Jack, having a pen that can write in 3 dimensions is like outside of the architects and people that are very smart with 3D, I'm blows my mind. What am I supposed to do with it? Where do I start? And that's the same thing I think across the board. As a user, it's these tools sound great, but we're so ill-equipped to even understand how to use our facial expressions and our emotions and gesture and 3D, pen magic. So how do you roll out solutions that provide the necessary cues to set your solutions up for success, And then what are some of the kind of unique user experience challenges, like my arms get tired, for example, that we should be discussing?
Can I so on that I see two different approaches. So actually I think that in this camp I'm sitting with you in MASSLESS, in that our mission is to use the same mechanisms that we normally use in everyday life and provide those to new environments. So we all know how to use a pen. Using a pen is very natural. Using a pen in an immersive or augmented environment is natural. We're all experts in using our faces. We use them all the time, and we're all four of us sitting here. We are doing this, talking to you in the audience. All I'm trying to do is to understand and interpret that and put that in the environment. So you're working on new contexts of using gestures to do things and building new ways of operating, and I guess that's a different sort of challenge, actually.
Well, actually, I disagree.
Excellent.
But
Another win.
But I think
Eric is just poking the fire over here.
Actually, I agree. So the way we always, or I always think about that kind of new way of interaction, especially in VR and AR, it's very simple. It's okay. How would I communicate if it was not a screen or a car? But what about if it was a human? So, okay, in my car, I want to raise the volume. How would I communicate that to you, right? I would do something like that or like that.
Yeah.
So that's exactly what we did in the car, right?
Okay.
If you want to draw something, how would I communicate with you about drawing something? I would do something like that, right? So I guess your pen, you use it like that, right? So it's always that I keep in mind. So how would I communicate with a human? Because that's, you know how to do that, right?
Yeah.
That's what you learn since you're born. So that's easy guideline to follow.
Cool.
I think what's interesting here as well is, fiction always sort of leads technology. Those are the thought leaders, people that can just don't have the constraints of physics or actually making things. They can just use their imagination to see into the future how we're gonna do things. So we're at this state in society in general where we've got these sci-fi films, we've got these novels like Ready Player One, and there's lots of other similar ones where it's kind of people have this in their mind, this way of using a computer in 3D, this immersive experience. Like if you see Iron Man, like people are already like, oh, so, yeah, you could do it that way. And I find there's sort of two types of people. You've got some people that just don't understand really much about technology, and they see all of this kind of fiction, science fiction, and they think that's already available to us. And they think that's already there, because it seems so natural for us to work that way. And then you've got the others who know a lot about technology and understand how difficult it actually is to achieve these things and think that's not possible, we're never going to get there. And I guess we're in the middle trying to pull them together so that they are become a reality. But I think that's that's the interesting thing. We are, as a society, a collective consciousness. We are all moving towards this 3D immersive way of working with digital information. And
I think, pardon, sorry, a key element that unlocked the natural interaction, it's the technology that you've got in the headset, stereo vision, and head tracking. The reason is that, if you take your example, drawing in the air, you mentioned it's very difficult to draw in the air. Actually, it's not difficult, it's impossible. Unless you can see in 3D what you are drawing.
Right.
And so thanks to VR and AR, now you can have that feedback. You understand what you are doing.
Right.
We've tried that many times. Draw with your finger in the air and manipulate on a screen. It's just impossible because you just don't understand what you're doing. Yeah.
So I'm going to get to an audience question, but I want to say something. So I do agree with you. I love this optimistic approach to the fact that we're born with these skills. But I will argue that we are brainwashed from the time that we are children to now to unlearn those natural skills with the current waves of computing. And so I think that's what's working against us. So I'm maybe just speaking for me. I'm not an artist. I'm not a sculptor. I don't work in 3D. I live in 3D, but I work and I communicate in 2D. And so it's almost having to unlearn these 2D skills in a way in order for us to get to that more playful, childlike, more natural, as you're saying, way of thinking, I think that's what we need to unlock. And so in that way, I feel like the generations that are going to benefit the most from what you're creating are the same generations that picked up an iPad and got it right away, right? That just had their slate cleaned. And so I think those are going to be the generations that we should be watching with AR and VR. And Eric wants to argue with me, but I'm going to take a question from the audience. So I think this is an important one. What, in your experience, are the effects when a user has a suboptimal interaction with a virtual environment?
It's killing the experience immediately.
Completely.
Yeah, it's easy.
And it lasts as well. It's hard to recover from it.
And then it's seen as a gadget, and okay, you use it one time and then don't use it anymore.
I think that applies to any piece of technology, though.
Yeah.
If you have a suboptimal experience with any technology, if it's not helping you, why would you use it?
And I think it's particularly true with the gesture, because again, that's a natural skill that you have, gesture, and if it doesn't react as you would expect in real life, that's just horrible and frustrating.
Same with voice assistants. It's
right
the same. If you have a certain expectation and that's high because you use this modality with other humans, which are obviously mostly perfect at it, and if the system doesn't deliver a good experience, you don't like it within seconds.
I have a couple of futurists in the audience that want to talk about spinal taps and brain waves. We're going to talk about that in a second, but I do want to just allow Graeme to help us understand the role emotion plays in all of this. Because we've talked about gesture, we've talked about input and controller, we've talked even about voice, but what role does emotion play in this immersive computing? How do you see it all fit in? What do we do with emotion?
Well, specifically in the context of talking about interaction, our expressed emotion is an important stream of information that informs what it is that we're saying. So the content of what we're saying is the most important, despite the internet stat that gets quoted many, many times. But the emotional intent that comes behind that, the way that we say things, the contextual, human contextual information is extremely important, and we are incredibly good at reading that subconsciously. We don't even realize that we're taking that information in. We think all we're doing is listening to the voice. Actually, we are taking in the tone and the intent of the conversation all the time and reading subtle information into that. There's the flip side of that, which is very briefly and outside the context of an interaction discussion, is that is in improving ourselves. So human augmentation in these environments. Our emotions drive our behavior. Our behavior drives our buying choices, how good we are at learning things, the impression that we gain of new technology or new people or whatever. It is fundamentally important to how we behave and perform. And so if you can understand emotion, and if your digital assistants and your computing technology can understand emotion, it has a much better chance of assisting you in the process.
Mm-hmm. And I think that's kind of key to loop back into that audience question about that suboptimal experience. Your technology could actually provide the necessary input and context of the user to these solutions to help avoid that suboptimal, experience. If you start to see that person being frustrated, they
Exactly.
could make their product act accordingly, especially on the voice side, right? If Siri, Alexa, Cortana could actually feel my frustration, which is real on a regular basis,
Completely.
then how would that change the experience?
And voice tone analysis is really the cutting edge of commercial deployment of emotion analysis at the moment. Facial expression and the other forms of visible emotional display are really the next wave beyond that, which is what we're working on at the moment.
And it is interesting because in all these waves of computing, we've been better understanding us as users and we're going more and more inside in a way. We had a GPS and now we have VPS. And so we've moved indoors, and then that next step, is it our emotion, and then is it our brain? And that is a great segue, Tom, into, Tom, can we speak of direct brain interaction, #BCI? I love this question. I'm going to find this user after. So let's talk about it. Eric, you talked about how real do we want it to be, and how much stuff do we want around us, and do we want to wear? Does BCI cure it all?
Well, I think when that technology will be real, and I think Elon Musk is...
Yeah, Elon Musk is working on it.
So that's the end of all our technologies, right? Because you don't need anything more than that, right?
I see. All of this technology?
Yeah, I mean, it's the matrix, right?
So, Ori, we're going to name this the BCI conference instead of AWE, I guess,
here we go.
long term. But how far away is this, do you think?
No idea, I don't know.
Okay.
I think I can add a little bit on that because I'm not personally into BCI, but in the lab where I worked in university, I worked together with Christian Herf, and he did the fundamental research that Facebook based their presentation on last year when they said, no, it was this year, I think, when they announced that they are working on a brain-to-text interface. And so they used his research to show that it's basically possible. But it's, from talking to him personally, I know that it's really, really far away. So that research is based on research done in a hospital where people that are really, really sick get their skull opened and then a mat of electrodes directly on their cortex. Some die because of that, because they need to.
Thank you.
Yeah, I mean, they are so seriously sick that they need to do it, because if they don't do it, they don't have any chance to live. And then what they do is, during these 1 or 2 weeks where they have their skull open, some of them accept to read some sentences aloud, not even thought. They read it aloud. And then based on this brain activity, they recognize like 10 words with 75% accuracy. So really low recognition rate, but it's a fundamental research. It's a breakthrough anyway, but this is, no technology at the moment is capable of taking such signals from the outside without being invasive. So we're really, really far away. That's my personal opinion, so we don't even need to bother about that.
Okay, no competitive concern. So everybody now bumped up to 14 people. They want to get real and they want to talk about government legislation. Should we go there? Well, it's all lit up now, we have to do it, I guess. So this one says, all of these use cases are great in principle, but will government legislation restrict consumer use? For example, the EU's rules on facial recognition and cloud storage. So I think this one has to talk about privacy, security. I think this is where we're getting at. You're all collecting information in some way. You know, what is your responsibility? How do government legislation impact some of the choices you're doing? And at the end of the day, you know, do you see this as a problem? Privacy, especially.
It's a huge problem, definitely. But it is a problem that can be overstated. So for our particular use case, we are capturing information about the way that people's faces move. Now, all of the information that we are capturing is information that you give to the world all the time. We're not connecting to your brain and finding out what you think. We're connecting by seeing what happens on your face. And those facial movements are your way of communicating with the outside world. So whilst there are privacy concerns around facial recognition and how that can be used, the actual process of capturing facial expression in itself is not a problem. There are significant issues around privacy, data storage, and the like that have to be really carefully addressed, because one of the things that hasn't been mentioned in this talk but is fundamentally important, and one of the big boosts to all of these interactions in the last few years is the rise of machine learning and the opportunity that large data sets give to significantly improve these very, very difficult, messy problems that we're all solving. In order for machine learning to be able to do that, we need lots of data. And we have to balance that need for data against the need for privacy. I could go on about it all day, but I won't. Anybody else?
Yeah, I think, so I don't think the issue is specifically on gesture or facial animation. It's really about data collection. And indeed, that influences your architectural choice of your system, right? Do you process locally or over the cloud? Do you collect data or not? But I don't see that as it's probably going to be long to solve, but it's not a major issue. I mean, if the service that we are providing is good enough, and I think it is, legislation will adapt to that, one way or the other.
Yeah. Certainly Amazon Alexa demonstrates quite admirably that people are quite happy to give up this kind of data.
Well,
Like
but that's the
everything
flip
you say.
side, yeah, that's the dark side of the system. Like,
Yeah.
Yeah, but that's in a consumer context. It's
Indeed.
totally different if you have a worker that wears an armband or is otherwise, his data is collected, and you then see by the end of the day he did 5 pauses, but he's
Right.
supposed to do 3 of them, and he smoked 20 cigarettes, and he's only allowed to smoke four. So I think then it's really different, and we need to take care that this information really stays personal in this case.
Okay. The last thing I think we have, we're running out of time, but I love this last question that was here. Let's go down the line, and if for any of the creators in the room, design thinking engineers, UX, and designers, you're all ushering in new inputs for them to use in some way. So maybe just, we'll start with Jack, but like what tips would you give to help guide them towards this new future of working in 3D or working with gesture or working with emotion? How would you set them up for success?
Yeah, I think this is a great question, and I think the interesting thing is, we are all pioneers in this area. This is completely new. So you're not a student. There are no rules that are set out. We are here to discover them all together. So this is an exciting journey for all of us. So what are the UX principles is the main question, I think, of the next years that we all here want to find out, and we all, that's what drives us to do what we're doing. But for sure, I can just get a bit more specific if you like. So we have never had 3D interaction on a consumer level before. So the paradigm of interacting with 3D things just doesn't exist. So it's great to try and take cues from like movies and things like this, where I try to draw a lot of inspiration, but really none of these are actual applications that do anything real. So a lot of these user interfaces are terrible as well. But you can think of just new sort of interaction paradigms. Like we have sliders, buttons, like menus and layout things in 2D. But now we can use 3D things like spheres, like having things on the surface of a sphere is interesting. And moving things by trying to twist a sphere is a cool thing to explore. But yeah, I guess it's just this is a new land we're all like exploring. So this is the exciting thing we're all doing.
Awesome, Christoph.
Yeah, I totally agree. I don't have too much to add on that, but just to throw away the 2D paradigm a little bit if you're a designer and try to rethink it from a 3D perspective and think about things that are already 3D, our world, and try to bring that in. But I think it's very open and we all don't know it yet.
Eric?
Yeah, I would give a couple of advice. I mean, that's the way I'm trying to do things. First, if you feel it's a good idea, just try it. Because you may think, okay, maybe it's not going to work, maybe it's going to be great. You never know. So first try it. And then, as I was saying, think about it as if you were interacting with a real person. Does that make sense? And then third thing, I would say, I think, is it improving your life, or is it making your life easier? And very important, is it making your life more fun? I mean, is it really great to do?
Yeah.
I think those are kind of guidelines, but I think the most important is just try it.
Graeme? Bring it home.
Yeah, so I'm not a creator and a creative, and I'm a machine learning expert, and I run a business. So I don't try to tell creatives what they should do. That's they bring so much back to the underlying technology that we provide. Some of the work that we have started doing with creatives involving having game characters respond to the emotional state of the player, or even changing the tone of the gameplay, the colors and the environmental aspects of the gameplay based on the arousal and positivity or negativity you're getting back from the player, though, are really interesting, and I look forward to seeing what people can do with that kind of technology.
That's fantastic. So I think the big thing I'd love you all to leave this room with is that when we talk about immersive computing, and even these small little 2 letters, AR or VR, it's much more than sight. So definitely let's expand the conversation and the horizon well past display and screens to really consider the fact that we are recreating everything that makes us human. And so I hope you're inspired from these amazing folks here on stage, and you want to continue the conversation. You can find them in the expo or at the reception later today. Thank you very much, guys.
Thank you, Tom.